So our goal is to talk about unit conversions. Now, either online in the notes or here, as you see in the back of your textbook, we will have a table for unit conversions. As you look at these, realize that these are supposed to be compared to 1. So these just have the prefixes and they don't actually have the meter or liter or whatever unit we're actually talking about. So this is supposed to be compared to, or trying to describe, how many of that unit it would take to give you that number. Let me show you what I mean. So if we were talking about a kilometer is actually pretty big. To get 1 kilometer, you need 10 to the third meters, or 1,000 meters. You can go ahead and put this 1 times 10 to the third. So this would also be 1 kilometer being equal to 1,000 meters. Similarly, when we're looking at these smaller units, if we pick something like micro, so if we wanted to talk about a single micrometer, 1 micrometer is really small. It's only 1 times 10 to the negative 6 meters. So that's how this table works. This table actually has an invisible 1 in front of whatever the prefix is, and whatever this number here is actually goes in front of the meters. That's how this table works. The thing to remember here is things like the fact that a kilometer is big. So kilometer should be relatively big. Micro. When we think about microprocessors, you think about micro being small. This means that that micrometer should be a really small thing when you talk about its conversion. So the hard thing is that you can usually find the reverse of all of these tables, which then gets really confusing really quickly. So I'm going to show you what the reverse of these two things would look like, but just keep in mind that you get to pick what you want to memorize because you just have to be able to use it. We're not going to ask you to spit back a table. So here's what I mean by this. Since we could say that 1 kilometer is 1,000 meters, or you essentially need 1,000 meters for 1 kilometer, you could also say that 1 meter is only 1 times 10 to the negative 3 kilometers. It looks kind of strange, but all we're doing is using a different base for our ratio. Where this is really more common is when you're talking about the small scale. Human beings in general like to talk about whole numbers. So this 1,000 meters looks really good. This 1,000th, or this tiny number, makes us uncomfortable. Similarly, this tiny number of 1 times 10 to the 6th of a meter doesn't make us very happy. So oftentimes you may see this flipped around to say, well, a micrometer may be such a small unit of a meter, so we could actually say that you need 1 times 10 to the 6th micrometers to equal 1 whole meter. So realize that when you're looking at any of these tables with these prefixes, usually the big units will look the same no matter what. It's the smaller units you have to watch out for. I'm the first to admit I'm guilty of this because when I was learning metric, they usually taught me to use positive number exponents for everything I did. So when we were in class, you were definitely going to see me use this version. I'm trying to break myself of this habit because I've realized a lot of you are looking at these sorts of tables, but it's hard to break a habit after so long. So I am doing my best, but please keep that in mind. So that's a little look at how these tables work.